Hi everyone, welcome to Do Maths with me. On this channel, we believe that practice makes perfect. That's why we are not just here to teach you math, we are here to do the exercises with you. Together, we will solve the challenging problems step by step. So you can learn from the exercises and I will explain the concepts along the way. If you are ready to unlock your full math potential, don't forget to hit that subscribe button and like this video to give me support. Let's get started! Today we'll be learning from 4M Math Chapter 7, Coordinate Geometry. These are the formulas related to this chapter and we'll be using them in the questions later. First, if you want to find a distance between 2 points, so let's say I have points A and point B. So in order to find the distance, I have A is x1, y1, and B is x2, y2. Then it's similar to the Pythagoras theorem, where we have the height here is x2 minus x1, and we have the length here. This will be y2 minus y1. So it's similar to Pythagoras theorem, where we have a right angle triangle, and this will be your A, your B, your C, and we'll say C squared equal to A squared plus B squared. And C will be equal to square root of A squared plus B squared. As you can see, this is very similar to the formula here, where the A will be x2 minus x1, the B will be y2 minus y1. So that's how you get the distance between 2 points. Next, for midpoint, let's say I have point A and point B, each with x1, y1, x2, y2. The midpoint here, let's say M, it will then be x1 plus x2 divided by 2 because you divide them into half. So you divide them by half. And same goes for your y, y1 plus y2 divided by 2. Then you get the x and y coordinate for the midpoint. If it's not a midpoint, let's say in this situation here, I have a P dividing AB into M and N. So we have to use the third equation here. To find x, I have to use x1 multiply with the opposite ratio and x2 multiply with the opposite ratio. That's why you can see here I have nx1 plus mx2 divided by the sum of the two ratio. So it will be n plus n. Same goes for your coordinate y. You have to use y1 multiply with the opposite ratio, y2 multiply with m, so you have ny1 plus my2 divided by m plus n. Last formula is to find the area. So let's say I have a triangle like this, and in order to find the area, I have to use 1 over 2 modulus. So I start with point 1, x1, y1, x2, y2, x3, y3, and remember, you have to repeat the first point before you close the modulus. So I have to repeat x1, y1, then I close the modulus. And how to get to equation like this? It's very simple. You just need to do multiplication, follow this direction. So you have x1, y2, x2, y3, and x3, y1. So from left to right is addition. You add them up. Next, you go to the opposite direction. x1, y3, x3, y2, x2, y1. And you minus all of them. So if I rewrite this equation, it will be 1 over 2 modulus x1, y2 plus x2, y3 plus x3, y1 minus x2, y1 minus x3, y2 minus x1, y3. Then I close the modulus. So remember, from left to right is always addition. From right to left is always subtraction. If you are using this formula for a polygon, let's say a rectangle here, when you write the formula, remember you have to follow the direction. So let's say I'm going clockwise direction. I have to write as x1, y1, x2, y2, x3, y3, x4, y4, And remember, rewrite the first one, then you close the modulus. So you can see I'm following the direction. 1, 2, 3, 4. I'm going this way. If you are going for the opposite side, you have to do this x1, x4, x3, x2. You can't mix them up. You cannot do x1, then x3, then x4 or x2. You have to follow the direction. If you are going clockwise, go x1, x2, x3, x4. If you are going opposite, then you have to do this direction. So that's it, the 4 formula for this chapter. Let's look at the exercises. First question, we have point A, B, and C lying on a straight line. So let's draw it out. A, B, and C. Given that AB equal to 2 over 5 AC, so AB equal to 2 over 5 AC. When we want to write the ratio between two different segments, we'll write at AB to AC equal to, let's say, M to N. In order to get this, we need to take this column as over. So AB over AC equal to M over N. So if you look back to here, we want to get the ratio of AB to AC. What we'll do is we'll move this AC to left-hand side. So it will become AB over AC equal to 2 over 5. So we change the over to column. So AB to AC will be equal to 2 to 5, which means AB is 2 and AC is 5, which means BC is 3 here. So that's how we get the ratio. So in order to express T in terms of T, we need to put the coordinate of A, B, and C into this drawing. So A is 2H and H, B is PT, and C is 2P, 3T. As we already have the ratio is 2 to 3 for AB to BC, we can use back the third formula in the previous slide. So we have B equal to 2H multiplied with the opposite ratio plus 2P multiplied with the opposite ratio, which means this X will be multiplied with 3 here and 2P multiplied with 2 here. That's how we get the X coordinate. And remember, divide by 2 plus 3. Same goes for the Y, H times 3 plus 3T times 2. Divide by 2 plus 3. And the B is PT. So we'll have 6H plus 4P divided by 5 and 3H plus 6T divided by 5. With this, we can then compare the X to the P here, and we compare the Y to the P here. For X, we'll say 6H plus 4P over 5 equal to P. So 6H plus 4P divided by 5 equal to P. 6H plus 4P equal to 5P. And 6H equal to 5P minus 4P. So we have P. So P equal to 6H. And for Y, 3H plus 6P divided by 5 equal to T. 3H plus 6T equal to 5P. So we have 3H equal to negative P. So H equal to negative T over 3. So we'll have 6 multiplied with negative T over 3 equal to P. So negative 2T equal to P. So express T in terms of T, we have the answer P equal to negative 2T. For B, it's given that gradient AC is 3, so we say MAC equal to 3 and T equal to 1. And find the equation of straight line that perpendicular to AC and passes through point B, which means at point B, we'll have a perpendicular line like this. So we have the MAC equal to 3 And remember, for perpendicular line, we have m1, m2 equal to -1. So this is only valid for perpendicular. If it's parallel, is m1 equal to m2, which means two straight lines have the same gradient. So in this case, is m1, m2 equal to -1. So in order to find the gradient of this perpendicular line, let's say m2, we'll say m2 equal to -1 mac, which is -1/3. And to find a straight line, we need to have a point, which is x and y, and we also need to know the m. So these are the key components to form a straight line equation. We already have the m, but we don't have the point yet, so we need to get the point. With t equal to 1, we know p equal to -2t, which is -2 multiplied with 1, and we get -2. So we can rewrite this point B into -2 and 1. So we already have the key component, -2, 1, and the m is -1/3. So y equal to mx plus c, this is the equation for a straight line. Put in all the components we have. 1 equal to m is -1/3, multiplied with -2 is the x, plus c. So 1 equal to 2/3 plus c. So your c will be 1/3. With c equal to 1/3 and m equal to -1/3, we can form the final equation. Y equal to mx plus c. So this will be your final answer. Next, we have a straight line PQ, and this is the equation. And we need to find the equation of straight line which is perpendicular to PQ and passes through Q. So we'll find straight line like this, and which is perpendicular to PQ and passes through point Q. And we know the equation for PQ is 3x plus 5y equal to 1. So 5y equal to -3x plus 1. And y equal to -3/5x plus 1/5. So the MPQ will be -3/5. And remember, if it's a perpendicular line, m1, m2 equal to -1. So this m2 for the perpendicular line will be -1 divided by -3/5. And we got 5/3. So the gradient of this perpendicular line will be 5/3. And we now need to find what is the coordinate for Q. As I mentioned before, to find a straight line, we need to have a coordinate, a point, and the m. So we now have the gradient, but we don't have the coordinate yet. At Q, which is when your y equal to 0. With y equal to 0, we have 0 equal to -3/5x plus 1/5. So 3/5x equal to 1/5. So the x will be 1/3. So we now know this coordinate is 1/3 and 0. So we now have the coordinate and the gradient. We can form the equation. Y equal to mx plus c. First we find the c. So y equal to 0 and m is 5/3 and x is 1/3 plus c. So 0 equal to 5/9 plus c, and your c is -5/9. Therefore, your final equation will be y equal to 5/3x -5/9. This is the final equation for the perpendicular line. Next, we have a straight line AB passes through a point M0 and has a gradient of m. Find the equation of AB in terms of m. So we know the gradient of MAB is m, and we know it passes through M0. So y equal to mx plus c we have y equal to 0 and the gradient is m multiplied with the x is also a m plus c. So 0 equal to m squared plus c and your c equal to negative m squared. So with gradient m and c equal to negative m squared, we can form the straight line. Y equal to mx plus c. The c is negative m squared. So y equal to mx minus m squared. Next, find the values of m if the line AB passes through point 1, negative 6. So we know that one point is 1, negative 6. Put it into the equation y equal to mx minus m squared. So the y equal to negative 6, mx is 1 minus m squared. So negative 6 equal to m minus m squared. So it's a quadratic equation. So m squared minus m minus 6 equal to 0. And we do the factorization. M negative 3 and positive 2. So we have m equal to 3 and m equal to negative 2. So m equal to 3 and negative 2 here. Next, find the equation of straight line AB if m is a positive. So just now we found that m equal to 3 and negative 2. And in C, it mentioned m is a positive constant. So the only answer will be m equal to 3. So m equal to 3. Hence, find the coordinate of the intersection point between a straight line and the curve. So for intersection point, it will be something like this. I have a curve and I have a straight line. So at this point, x, y, it will fulfill the function of this curve and also the straight line, which means that at this point, y1 will be equal to y2. So let's say the y1 is the curve and the y2 is a straight line. So this x and y can be put into both equations. So we know the equation for the curve is this one. X squared minus y equal to 7 minus 6x. So x squared plus 6x minus 7 equal to y. So this is the equation for the curve, and we want to know the equation for the straight line. With m equal to 3, we know y equal to 3x minus 3 squared, which is y equal to 3x minus 9. So this is the y1 and this is the y2. So we say y1 equal to y2. 3x minus 9 equal to x squared plus 6x minus 7. So we move everything to the right hand side. X squared plus 6x minus 3x minus 7 plus 9. 0 equal to x squared plus 3x plus 2. And we do the factorization. X plus 2, x plus 1. We have x equal to negative 2 and x equal to negative 1. As we know y equal to 3x minus 9, when x equal to negative 2, y equal to 3 multiplied with negative 2 minus 9. So negative 6 minus 9, and we have negative 15. For x equal to negative 1, we have y equal to 3 multiplied with negative 1 minus 9. So negative 3 minus 9, we have negative 12. So this point will be negative 2, negative 15. And this point is negative 1, negative 12. It can fulfill the requirement of the curve intersect with the straight line. So these are the answer. Next, we have straight line BCD, and we have a point A here. It's given the coordinate for B, C, and D, and they are collinear such that BC to CD is with the ratio m to n. And we need to find what is the ratio. So we have BC to CD equal to M to N. And C is dividing BD into two segments. So here will be M and here is the N. And with the third formula in the first slide, we know that C will be equal to -3 multiplied with N plus 7 multiplied with M divided by M plus N. P multiplied with N plus 6M divided by M plus N will be your Y. So we compare the X to the X. 3 equal to -3N plus 7M divided by M plus N. And compare the Y to Y. So we have 4 equal to Pn plus 6M divided by M plus N. 3M plus 3N equal to -3N plus 7M. So we move the 3N to here. 3M plus 3N will be equal to 7M minus 3M. So 6N equal to 4M. And to find the ratio of N to N, we need to find M over N. So this will be 6 divided by 4 equal to M divided by N. Then it will be 3 over 2 equal to M divided by N. So the ratio of N to N will be 3 to 2. So this will be 3 to 2. So to find the value of P, we need to compare the Y here. As we already know, the ratio of M to N is 3 to 2. So we can say when M equal to 3, N equal to 2. So we put them into this equation here. 4 equal to P multiplied with 2 plus 6 multiplied with 3 divided by 3 plus 2. So 4 equal to 2P plus 18 divided by 5. 20 equal to 2P plus 18. So 2P equal to 2 and P equal to 1. So the answer is P equal to 1. Next, we have to find the area of this triangle ABD. So to find the area, we need to use the last formula from the first slide. So for point number 1, let's say we start from A. So A is 0, 9. X equal to 0, Y equal to 9. And we have D is 7, 6. And we have B is -3 and 1, as we already know P equal to 1. So we put in 0, 9, and then 7, 6. Next will be -3, 1. And remember, repeat the first one again before you close the modulus. So this will be 0 plus 7 multiplied with 1 plus -3 multiplied with 9. Then we minus 0 multiplied with 1, -3 multiplied with 6, and 7 multiplied with 9. So minus 0 minus -3 with 6 minus 7 with 9. And we close back the modulus. So 1 over 2 modulus 7 minus 27 plus 18 minus 63. So we have 1 over 2 modulus -65. So it will be 1 over 2 multiplied with 65, as the modulus has turned the -65 into a positive, and we got 32.5 units square. Last question. We have point A, B, C, and D, and we have M, which is the midpoint of AC, and B lies on the perpendicular bisector of AC. So the perpendicular bisector of AC means that for line AC, at the midpoint, there's a perpendicular line. A bisector means that it divides line AC into half. So start from this midpoint, there's a perpendicular line which passes through B as well and is 90 degrees to the AC. So first we need to find the equation of this perpendicular bisector of AC. So we have to know what is the gradient of AC, so we can know what is the gradient for the perpendicular line. So MAC will be equal to y2 minus y1 divided by x2 minus x1. So let's say point 2 is A and point 1 is M. We have 9 minus 3 divided by negative 9 minus negative 5. So it will be 6 divided by negative 4. So the answer will be negative 3 divided by 2. So for the perpendicular line, M2 will be negative 1 divided by MAC, which is negative 1 divided by negative 3 over 2. So we get the answer is 2 over 3. With this gradient and with the point M, we can form the straight line y equal to mx plus c. So we have point negative 5 and 3. So y equal to 3 and m is 2 over 3 and the x is negative 5 plus c. So we have 3 equal to negative 10 divided by 3 plus c. So the c will be 19 over 3. So with this, we can say the equation is y equal to the gradient 2 over 3x plus 19 divided by 3. And we can multiply all with 3. We have 3y equal to 2x plus 19. So this is 3y equal to 2x plus 19. So to find the area, we need to know each of the coordinates, but we don't have the coordinate for C yet. So in order to find the coordinate for C, knowing that M is the midpoint, we can use the second formula from the slide. M, negative 5, 3 equal to negative 9 from point A plus, let's say this is x and y, x divided by 2 and 9 plus y divided by 2. And we compare the x to x, y to y. So negative 5 equal to negative 9 plus x divided by 2. Negative 10 equal to negative 9 plus x. So x equal to negative 1. 3 equal to 9 plus y divided by 2. 6 equal to 9 plus y. And y equal to negative 3. So we have the xy here become negative 1 and negative 3. So we have the coordinate for C, but we still need to find the coordinate of B. We know that this B lies on the perpendicular bisector, which is this equation that we just found. So we have the point negative 8 and k put into this equation. So y will be the k equal to 2 multiplied with the x is negative 8 plus 19. So we have 3k equal to negative 16 plus 19. 3k equal to 3, so k equal to 1. So we know this is negative 8 and 1. With all the coordinates, we can now find the area. So area equal to 1 over 2. And remember, for polygon, we have to follow one direction. So let's say we know it's clockwise. So we have to start from A, B, C, then B. So negative 9, 9, 1, 9, negative 1, negative 3, negative 8, and 1. And remember, repeat the first one before you close the modulus. So 1 over 2, plus, 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 and minus, 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 minus. So negative 9 multiplied with 9 plus 1 multiplied with negative 3 plus negative 1 with 1 plus negative 8 multiplied with 9. Then minus negative 9 with 1 minus negative 8 with negative 3 minus negative 1 with 9 minus 1 with 9. Then we close the modulus. So we'll have 1 over 2. So this is negative 172. And with the modulus, we remove the negative. So the final answer will be 86 unit square. So next, we have a circle, which is a locus of point P. And point P is moving such that its distance from point A is always 10 units. So you'll have a circle like this. And from here to here is 10. which means the radius of this circle is 10. So we need to find the equation of the circle. Then we need to determine whether this point P lies on the circle or not. So remember the first formula on the first slide, where we have distance equal to square root of x2 minus x1 square plus y2 minus y1 square. So this distance here represents the 10 units. So we have 10 equal to square root of x minus, so the x1 and y1 here will be your A. So let's say I delete here, and you have a circle. Then you have a distance from here to here is 10. So you have this point is x and y. So the distance from this point to the point A is 10. So your x1, y1 will be this moving point, and the x2, y2 will be your fixed point A. So x minus -9 and square plus y minus 9 square. And we change the position of this square root to left hand side, and it will become a square. So 10 square equal to x plus 9 square plus y minus 9 square. Then we expand the bracket. So 100 equal to x square plus 18x plus 81 plus y square minus 18y plus 81. Then we move the 100 to the right hand side. X square plus y square plus 18x minus 18y, and the number add up together. We have positive 62 here. So this will be the equation for the circle. And to check whether point P lies on this circle or not, we just need to put in the coordinate of B into this equation. If it fulfills the equation, it means that it lies on the circle. If not, it doesn't lie on the circle. So let's check. So we have B is -8 and 1, and we put it into the equation. X is -8 square plus y is 1 plus 18 times -8 minus 18 times 1 plus 62. So we have 0 equal to -35 on the right hand side. So it does not tally, which means B does not lie on circle Z. As it does not tally, we know that B does not lie on the circle. So that's it for this question. And that's all for today. We have completed these math exercises together step by step. Now it's your turn to try. I have put a link to this question in the description box, so try it out if you can solve these exercises on your own. Remember, practice is the key to mastering math. Keep challenging yourself with more exercises and watch your skill grow. Don't forget to subscribe to Do Maths with me for more math exercises. Keep up the great work, keep learning, and see you in the next video. Bye-bye!